Buffers, is that the most exciting thing? Okay. I heard some mumbling yeses with some enthusiasm. We did a lot of isotables actually. We just did common ion. You can have common ion with acids as well, but we did a common ion example. So we did a couple of these actually. Let me talk about buffers and kind of an overview of buffers. First, a common what is buffers, is this a buffer sort of question could come in a multiple choice. And you're looking for usually three things. An acid and its conjugate base, they both need to be weak, or you can think of it from the reverse, a base and its conjugate acid. These two need to have similar molarity within a factor of about 10. Similar molarity. And then, doesn't always come into play, but you need to have a relatively large volume, or a large amount, if you want to be more generic of it. Okay, so the first two are the ones that come into play. We've seen already the Henderson-Hasselbalch. Okay, I think there are three sorts of problems that could come, types of questions that could come. One is your classic, just find the pH. That one's probably the easiest for most people. Slightly more difficult is to find the amount of acid or base and or base given the pH. So it's the reverse direction, a little bit more difficult. And then three is if you add either a strong acid or a strong base to a buffer. Probably the most difficult style of problem when you add something to a buffer. In this case, in 3, you'll need to do stoichiometry first, then, and it's always going to be stoichiometry when this happens, and then you're going to go to the Henderson-Hasselbalch equation after that. So realizing and doing the stoichiometry is usually the toughest part. Let's say we have a buffer. Let me see if I can think of an example for number 3. Let's say we have this buffer. And let's say it's 1 molar. And let's say there's 1 liter of it. Okay, first of all, is this first one the acid or the base? The acid is the one that has the hydrogen, or the less negative charge. Okay, so the conjugate base would be this one. The K for this one, because you'll need the pKa eventually, it's a Ka, but there's something else to it. Does anybody know what it is? The K. It's not Ka, it's Ka2. Close. Yours 50% there. Okay. Remember, scratch, apparently, let's see, this will be, this one's 1. Goes to the HCO3 minus plus, dot, 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 more stuff. 2 is this one, plus water, goes to the CO3 2 minus plus more stuff. Okay? So this would have a Ka2, or you'd want to find a pKa2. Did I say that right? pKa2 in order to use the Henderson-Hasselbalch eventually. That's going to be one issue with this one. Okay? The second one, I'm going to pick one that was more exciting for us. Okay, the other thing, now let's say I'm going to add, do you like acids or bases then? Of course, acids. Okay, let's say we want to add HCl, one of our favorites, and we're going to add 0.010 moles. So usually given an amount, usually it's in moles. It could be in grams, you just have to convert. All right, so this is going to react with bicarbonate or carbonate. Which one? Carbonate. An acid will always react with a base, so you want to pick the opposite one of the buffer. So if you're going to write the stoichiometry reaction, you'd write CO3 2 minus plus the acid. I like to write the acid just as H3O plus, but if you prefer HCl, totally fine. And that becomes HCO3 minus plus H2O. Stoichiometry reactions are just typical acid-base reactions, but not something that you would have memorized ahead of time. You have to just generate this from scratch, knowing that the base gets a proton and the acid loses a proton. So that's something you'd have to generate. And then you're going to write the numbers here. So as somebody pointed out earlier, we prefer moles in stoichiometry. This was 1 molar, but because I had 1 liter, it's also 1 mole. This is 0.010 moles, and this was 1 mole. So I'm going to subtract the smaller one and add it here. 0.99, 1.01. There we go. So then you just go pH equals pKa, but we already know it's pKa2. You'd have to be given on an exam, on a final, you'd have to be given Ka2. Likely, if it was from a polyprotic, this is from a polyprotic, we'd probably give you Ka1 and Ka2 and make you decide which one's the right one. Okay? That would be just a typical thing we would do if it was one of these. Plus the log of the base over the acid. What units do I want here? It's defined by molarity, but because they're at the same volume, you can just put it in moles. Like the other one we saw a little bit earlier. Base, make sure you just know which one's the base. Okay, couple questions. Is it going to change the pKa2 or the pKa a lot or a little? A little, because it's a buffer. Otherwise, you've messed up badly somewhere. Is the pH going to go up or down from the pKa? Down because I added an acid. So I'm expecting it to go down a little bit at least. I just made this up, so I don't know what it is, but you can calculate that. Okay, we're getting just a bit past 8. I got to everything I could. I talked about acids. Boom. So looks like we got about 2/3. Let me just say something before everybody's dismissed. Hopefully this was helpful to you, at least what we could get through.